In this section, we will learn how to measure EMG signals using electrodes and an electromyograph. EMG signals are electrical signals that are generated by the muscles when they contract. They reflect the activity of the motor neurons that control the muscles. By measuring EMG signals, we can monitor the muscle function and control a robotic arm with our muscles. To measure EMG signals, we need two main components: electrodes and an electromyograph. Electrodes are small devices that are attached to the skin or inserted into the muscle. They detect the electrical activity of the muscle fibers and convert it into electrical signals. An electromyograph is a device that amplifies, filters, and displays the electrical signals from the electrodes. There are two types of electrodes: surface electrodes and needle electrodes. Surface electrodes are placed on the skin over the muscle of interest. They are non-invasive and easy to use, but they may pick up noise from other muscles or sources. Needle electrodes are inserted into the muscle with a fine needle. They are more invasive and painful, but they provide more accurate and selective measurements of individual muscle fibers. To measure EMG signals, we need to place at least two electrodes on the muscle, one for recording the signal and one for reference. The reference electrode is usually placed on a bony or inactive area, such as the elbow or wrist. The recording electrode is placed on the muscle belly, where the signal is strongest. The distance between the electrodes should be about 2 centimeters. The electrodes are connected to an electromyograph, which amplifies and filters the signals. The electromyograph may also have a display that shows the signals as waveforms or numerical values. The electromyograph can also send the signals to a computer or a robotic arm for further processing and analysis. By measuring EMG signals, we can obtain information about the muscle activation level, contraction force, fatigue, and coordination. We can also use EMG signals to control a robotic arm with our muscles. For example, we can place electrodes on our biceps and triceps and use them to flex and extend a robotic arm. We can also use EMG signals to control more complex movements, such as grasping or reaching, by using multiple electrodes and advanced algorithms. This is how we can measure EMG signals using electrodes and an electromyograph.